Good morning, friends. Today we are going to see how to solve linear programming problem graphically. There are some methods to solve linear programming problem, but graphical method is easier one to find out feasible solution, feasible region, and optimum solution. So today we are going to see very interesting chapter, very interesting concept, that is linear programming problem. This concept is actually applicable to business administration courses and uh, some other statistics courses also. This is come under decision science for MBA courses. So today we are going to discuss very interesting and in easier way how to solve linear programming problem with graphical solution. I'm going to see you how to calculate, how to draw graph on it, how to plot numbers, then how to find out feasible and optimum solution of it. So this is my PPT. So, first of all, the concept is what linear programming problem. It includes some linear equations. Linear equations are those equations having some variables and some arbitrary constant numbers also. There are x and x and y are variables. To know the concept of variables in detail, you can go to my YouTube channel, and there is a PPT of there is a lecture of variable, so you can see that video, and you can have clarity on the concept of variable. But here just consider x, y, and z. These are the variables here in this PPT. It is there is one equation, that is p is equal to ax plus by plus cz. So this is a equation. This is a linear equation actually. In linear programming problem, it is called as objective function. Here x, y, and z are variables, and a, b, c are arbitrary constant, we can say. Okay, these variables are called as decision variables. Constraint means there are some limitations when a objective function is set for an organization. So if p is an objective function, then there are some limited resources which have impact on objective functions are called as constraint. Okay, always in a linear equation, x and y are greater than or equal to 0. This condition is called as non-negativity condition in linear programming problem. Always x and y and whatever variables are there, always that variables are greater than or equal to 0. That is non-negativity condition. We find out solution, feasible solution, where all the constraints are satisfied. That solution is called as feasible solution in linear programming problem. Generally, for linear programming problem, we call it as LPP. Okay, so we will find out feasible region, and on the points where you can find out your solution feasible, that points are called as point of intersection of that particular region, and that solution is called as feasible solution, where our objective function achieved. Okay, for example, if your objective function is like maximize p is equal to something, and at the point where you got objective function's value is maximum, that point is called as optimum solution in linear programming problem. So let us say we'll discuss this concept with the help of an example. We'll draw graph for this example. We calculate point of intersection of variables and of that particular equations. Linear programming problem include linear equation having two or more variables. Okay, now let us say this is an example. This it is on your screen. Solve the following linear programming problem graphically. The linear programming problem is given as maximize z is equal to 3x plus 4y, subject to x plus y is less than or equal to 6, 2x plus y is less than or equal to 8, and x and y are greater than or equal to 0. Whatever concept we have discussed, that all these concepts and all the constraints and equations are given in this problem. Z is your objective function. Okay, and your objective is maximize z. That means we are going to identify, we are going to find out maximum value of z. That point we are going to find out. At that point we need to identify what is the value of x and what is the value of y, where we can get maximum value of z. That solution will be called as optimum solution of this linear programming problem. So maximize z is equal to 3x plus 4y is your objective function. Then subject to, so there are some constraint. We need to have maximum value of z, but there are some limitations. That limitations are x plus y are less than or equal to 6. Addition of x and y must not be greater than 6. It must be 6 or less than 6. This is first constraint is given. And the second constraint is 2x plus y is less than or equal to 8. This is constraint number 2. So first one, z is equal to 3x plus 4y is your objective function. And subject to these two equations are your constraint. X and y are greater than or equal to 0. This is non-negativity condition. So there is very simple method to calculate and to have solution of such linear programming problems. We are going to draw linear programming problems graph first, and then we'll solve, we'll identify the coefficient of that particular points and that correlation points, and then we will find out feasible solution and optimum value of that particular LPP. Now let us say your equations, you all know your equations. Okay, the equations are like, there are two equations in your LPP. The objective function is z is equal to 3x plus 4y, and two equations, x plus y is less than or equal to 6 and 2x plus y is less than or equal to 8. To solve linear programming problem, the first step is, first of all, consider all your constraint into equalities. It means non-negativity conditions, less than or equal to condition, that means inequality conditions. Less than or equal to, it means it may be less than or equal to, so it is not confirmed. Okay, so value of x plus y is equal to 6 or 5, 4, 3, anything which is less than 6. But here, to solve and to plot a graph, first step is we need to consider inequalities into equality. So here x plus y is equal to 6. That is first inequality we have considered into equality. We can say this is your example. This is your equation number 1. Then second constraint is given 2x plus y is less than or equal to 8. Okay, so this is your, we have considered 2x plus y is equal to 8. So this is your equation number. Let us suppose this is your equation number 2. Now we have two equations. Now we are going to plot a graph. These are the equations of lines actually. Okay, equation of line which we can plot on a graph. Okay, so to plot a graph, we need to have a point of intersection of that particular line on x-axis and y-axis. Then only we can plot that graph. So by using equation and putting value of x is equal to 0 and y is equal to 0, we can get point of intersection on x and y for that particular line. So the way to calculate point of intersection for the particular line is, consider equation number first. Here I have considered that equation number first, that is actually x plus y is equal to, this is equation number 1, x plus y is equal to 6. First of all, we have to put value of y is equal to 0 in equation number 1. This is your equation, and here I have already typed here 0 instead of y. So x plus 0 is equal to 6. Here you will get value of x. X is equal to 6. When x is equal to 6, y is equal to 0. In the same equation, we need to put now x is equal to 0. Okay, vice versa, you can do that. You can put value of x is equal to 0 first and then y is equal to 0. You'll get same answer. So now put x is equal to 0 plus y is equal to 6. you will get value of y is equal to 6. So point of intersection for that particular particular line, you have got a 0 and 6. That means 0 on x-axis and 6 on y-axis. So equation number 1, you got 2 points, 6, 0 and 0, 6. Okay, now come to equation number 2, your constraint number 2. Your constraint number 2 is 2x plus y is equal to 8 here. So now same thing we are going to follow. Put y is equal to 0 first, you will get value of x, and then put x is equal to 0, you will get value of y. So very simple. Here 2x plus 0 is equal to 8, so you will get value of x is equal to 4. 2x is equal to 8, so x is equal to 4. It means you got a point that is on x-axis is 4, and at the same time y is equal to 0. Now put x is equal to 0 in the same equation here. So 0 plus y is equal to 8. You will get a value of y. Y is equal to 8. So at this point your x is 0 and y is 8. Now for the equation number 2, again you got 2 points, that is 4, 0 and 0, 8. For understanding purpose, you can give names to this point also. You can give the equation number 1, you can write it as a 60. Here you can denote this point as b is equal to 60, then c is equal to 40, and d is equal to 0, 8. That way also you can identify, and you can give names to this point so that it will be easier when you plot a graph on it. Okay, now you got 4 points, 2 equations, and you got 2 points for each equation to plot a graph. Now I'm going to see you very interesting task, actually very interesting thing which we are going to do. We are going to draw a graph for this equation. So let me open my whiteboard. I hope this is visible to you. Okay, this is how we can plot a graph. Always x-axis. This is your x-axis. Just a minute. This is x-axis, and this one is y-axis. Okay. So x-axis and y-axis. Now we can have that points. Okay, we can have 4 points. Okay, on the on these calculations. For equation number 1, we have 0, 6, sorry, 60, then 0, 6. Then for equation number 2, 40 and 0, 8. Same thing, 60 and 0, 6. That line we are going to plot on this graph. Okay, what is the line? What is the equation? Let me add that equation here, the points here. For example, the point is point A. It is 0 and 6. Okay, then point we can say B is 6. Point, I'm so sorry, point A is 6, 0. Point B is 0, 6. Okay, point C, that means for equation number 2, 4, 0, and next one is 0, 8. So point C we can say is point C, we can say 4, 0, and point D we can say it is 0, 8. Okay, if for example, if we erase this part and if we do not denote this point here, then we can do like we can have some other nominations already I have given. So I'll do that numbering part after drawing this graph actually. So now come to drawing a graph. So the first point is what? First point is 60. So 6 on x-axis here. Okay, you need to define your scale on x and y axis. Okay, and you need to write down here. For example, if your scale for 1 centimeter on graph, 1 centimeter is equal to 1 unit or 1000 unit or 100 unit, whatever units you have chosen at the time of choosing your scale, you need to write down on x-axis 1 centimeter is equal to, for example, if you have taken it as a 1 unit, then you need to define your axis here, and y-axis, on y-axis 1 centimeter is equal to 1 unit. Here on x-axis I've already given units for 1 centimeter, 1, 2, 3, 4, 5 and 6 for 6 centimeter, and on y-axis same um, scale I have drawn here. Whatever scale you choose for x-axis, same scale you need to choose for y-axis also. That will be easier one to calculate feasible region and optimum solution. So the first equation, the first point is 60. 6 on x-axis here. Okay, 6 on x-axis and 0 on y-axis. Here it is 0 and 0 point here. This is your point, this is your origin, we can say, and it is 0 and 0 for both the axis values. Okay, this is O 0 0, we can say. Just a minute. Okay, here is 0 0. So your first point is 6, that is 6 0 here, somewhere here. Okay, and 0 is already here. And your second point on y-axis is what? It is 0 6. Here it is 0 6. Now we need to join these two points. This is the way we need to join these two points. I hope you all are getting me. Okay, this is your equation number 1 line. This is your x plus y is equal to 6. This is your equation number 1, and this is a line you have plotted on a graph. Now equation number 2. Equation number 2, that is line number 2, the point of intersections for x-axis. First point of intersection is 4 0 and second is 0 8. 4 0, this is the point. 4 0, and the second one is here 0 8. Somewhere here. Okay, so we need to join these 2 points to get plotted line of equation number 2. So this is your equation number 2 line. I hope you all are with me, you're getting me. Okay, so these are the 2 equations of a line. Now I hope you got this, how to plot this. Okay, if graph paper is available, you can draw it on a graph paper. If not, directly on paper, on answer sheet or on a notebook A4 size paper, you can draw it very easily. Here the scale is very easier one. For 1 centimeter we have taken as a 1 unit. Same for x and y axis. Now the next part is we need to calculate, we need to identify feasible region. Okay, we need to find out region where all your constraints are satisfied, that is called as feasible region. Okay, that means your objective function like z is equal to 3x plus 4y, that equation, that constraint will be satisfied or in that particular region. That region we are going to find out in this, on this graph. Okay, so again we have converted inequalities into equalities to plot a graph. But now again, we need to consider inequalities here. Okay, inequalities. What were our inequalities? 2x plus y is less than or equal to 8 and x plus y is less than or equal to 6. Okay, that was your we can say our solutions, our equations. Okay, so just okay. So now let us find out our feasible region. I hope this is visible to all of you. Now consider our inequalities. That is, 2x plus y is less than or equal to 8 and x plus y is less than or equal to 6. So how to find out feasible region and how equalities play a very important part, and it helps us to find out our feasible region. Always remember, guys, if your solution, if your equation is consisting less than or equal to value, for example, x plus y is less than or equal to 6, always your feasible region will be towards origin. Okay, from that particular line where we have drawn this line, your feasible region will be towards origin when inequality is like less than or equal to. When inequality is greater than or equal to, then always your feasible region will be opposite to origin. That means whatever line is there, from that line, open ended, That means opposite to origin part will be the feasible region. So here in this particular equation, your in both the inequalities, both the constraints are less than or equal to type of inequalities. So equation number 1, that is x plus y is less than or equal to 6. This is the line actually for this is the line for equation number 1, x plus y is less than or equal to 6. So here this is the line, and towards origin, that means this side, okay, towards origin will be the feasible region for this particular line. So we can say that this region, this region, the on the graph towards origin will be, I'm so sorry, towards origin will be the feasible region for equation number 1. Okay, so this will be portion will be in the feasible region. Okay, now consider equation number 2, that is 2x plus y is less than or equal to 8. Okay, now 2x plus y is less than or equal to 6. This is the line. Okay, this is the line for equation 2x plus y is less than or equal to 8. Now again the inequality is towards origin, so feasible region will not be this side. No, it is, it will be towards origin. So for this equation, this line, the feasible region will be towards origin. Okay, now to identify feasible region, I have used here green color and red color lines. Okay, different type of pen or different color pen or pencil you can use to identify feasible region. Now we need to identify a region where both the color lines are there. Okay, the region where both color lines are there, that region will be your feasible region. So here there are mainly there are three regions here. Okay, this triangle and this rectangle is there. Okay, so this polygon is there actually. So there are three regions. So the portion A, this is origin, we can say this is O. Okay, we can say this is origin O. Then this is point D, we can say this is D. Okay, D, and this one, there is a point that is intersection of two line. Okay, we denote it as E. Okay, and A. So this is a polygon A, O, D, and E. This is a region where both the colors lines are there. So this is your feasible region. A, O, D, E. This is the feasible region. Just give me a minute. I'll highlight it. Just a minute. So this one, A, O, D, E, and A. This is your feasible region, and there are 4 points A, O, D, and E. We all know that on point of intersection O, where x is 0 and y is 0, there we'll get a value of objective function is equal to 0. So here we can consider our point of intersections are 3. A is 0, 6 here. Already, what is this? A is equal to 0, 6. The point A is on 0, 6. So 0 at x-axis and 6 at y-axis. So A's point of intersections are 0, 6. O's point of intersection we already know, that is 0 and 0. Then D. Here this is point D. Again we know the D's point of intersection, that is 4 on x-axis and 0 on y-axis. Then for E. But here for point E, we don't know value of E. But point E is intersection of two lines. And the two lines are 2x plus y is equal to 8 and x plus y is equal to 6. Now to identify point of intersection for point E, we need to solve these two line equations simultaneously. And the way to solve two simultaneous equation, here I'm going to show you. So first of all, write down your equations. Equations like 2x plus y is equal to 8 and x plus y is equal to 6. These equations, these are linear equations. We need to solve these equations simultaneously. Okay, so first of all, we can add and minus. The method to solve simultaneous equations, we can add two equations or we can deduct one equation from other one. So here I am deducting x plus y is equal to 6 from 2x plus y is equal to 8. Here 2x plus y is equal to 8 and x plus y is equal to 6. I am subtracting second equation from the first one. So 2x minus x will be x, right? Here y minus y will get cancelled, that is 0. Y minus y plus y minus y will get 0. Then x here, then 8 minus 6. 8 minus 6 will be 2. So here x is equal to 8 minus 6 is 2. Here you get value of x. X is equal to 2. By subtracting x plus y is equal to 6 from 2x plus y is equal to 8. Now you got value of x. You can put value of x is equal to 2 in any of the equation. In 2x plus y is equal to 8 or in x plus y is equal to 6. In any of the equation you can put value of x, you will get value of y. Okay, so here let us suppose x plus x plus y is equal to 6. Here I'm putting x is equal to 2. That is 2 plus y is equal to 6. So we'll get value of y. Y is equal to 6 minus 2. So y is equal to, so y will be 4. Okay, so your point of intersection for point E is, your point of intersection for point of intersections for point E is equal to 2 on x-axis and 4 on y-axis. We call it as E. E is equal to 2 and 4. Here on this window I have already taken E is equal to 2 and 4. 2 on x-axis and 4 on y-axis. So this is your feasible region and these are the point of intersection for that particular feasible region. Now we are going to find out our optimum solution. Optimum solution means what? In your objective function, it is given maximum value of z at x and y. Okay, so we need to find out maximum value of z. We need to check actually maximum value as of value of objective function at these 4 intersection point. So z is equal to, it is already given, your objective function is maximize z is equal to 3x plus 4y. I hope this is audible. and visible to. Okay, so z is equal to 3x plus y. Now we are going to calculate z value at a. A is 0.6. So z at a 0.6 is equal to 3 multiplied by 0 as x is equal to 0 plus 4 multiplied by 6 as y is equal to 6. Here z at 0.6 is equal to 24. Okay, 4 6 are 24. 3 multiplied by 0 is 0. So z is equal to 24 when your x is equal to 0 and y is equal to 6. Now we'll find out z is equal to value of z when x is 4 and y is 0 at point D, which is here. At point D, which is here. Okay, so z is equal to 3 multiplied by 4 as x is equal to 4 plus 0 multiplied by a y value, that is 0. So it is 12. So z at D is equal to 12. Now the third point, E, point of intersection, which is here actually. So here for this point we are going to calculate value of z. So z is equal to 24 actually. Just a minute. Z at E 2 and 4. So 3 multiplied by 2 plus 4 multiplied by 4, that is 2 3s are 6 plus 16, that is 22. So Z at E 2 and 4 will get value is 22. Now we have and one more point at point of intersection O, that is 0 0, Z is equal to 0. We can write here that also if you want. Okay, so Z is equal to 0 at O, which is 0 and 0. I hope you all are with me. Okay, so now optimum solution is nothing but where we achieve our objective function, and here our objective function is z, maximum value of z. Now from all these point of intersection A, D, E and O, the maximum value will get z is equal to 24 here. So maximum value of z is 24, and this value is at point z is equal to A, that is 0 and 6. It means what? Objective function z is maximum when x, that is a variable, when x is 0 and y is 6. And both the constant will also follow. Okay, both constant will follow. It means 2x plus y, okay, 2x plus y is less than or equal to 8 always. You can cross check it. If x is equal to 0 and y is equal to 6, if we put these values in first constraint, that is 2 multiplied by 0 plus 6 is equal to 8, then in that case that constraint is already going to follow. The value will be how much? If you put x is equal to 0 and y is equal to 6, okay, then constraint will follow. Again x plus y, whenever when we put value of a06, then that constraint will also follow. That constraint will follow this. It means it is already it is a feasible, and your optimum solution is z is equal to 24 when x is equal to 0 and y is equal to 6. Okay, so this is how we calculate optimum solution of linear programming problem, feasible solution of linear programming problem, and graphs also. So here you guys have to remember that to solve linear programming problem, first of all, we need to consider inequalities into equalities. Then we need to identify point of intersections for each line that we can calculate by putting value of x is equal to 0 and then y is equal to 0 in particular equation of line. Then we'll get point of intersection. Then we have to plot a graph. For plotting a graph, we need to fix a scale for x and y axis. For 1 centimeter, whatever unit you are allocating, you need to write it down. Then you need to plot a graph. Then again, to find out feasible region, consider inequalities which are given in the equation, main equations. Consider equalities. Remember, when your inequality is less than or equal to type, then the region towards origin region will be your feasible region. If the inequality is greater than or equal to, then feasible region will be opposite to origin. That region may be unbounded feasible region, but if it is less than or equal to, then always your feasible region will be bounded one. Then you will get your feasible region. That shape may be anything. At the point of intersection, at the extreme points of the feasible region, we need to check the feasibility and we need to calculate value of our objective function. Okay, in the same equation, if your objective function is like minimize z, then at the point wherever you get minimum value of z, that point we have to consider as a optimum solution. But here your objective function is maximum, and maximum value of z is at point at point A when x is equal to 0 and y is equal to 6. So this is your optimum solution. This is all about calculating solution of linear programming problem by using graphical solution. If you have any doubt regarding this, you can just put your question in the chat box, in the comment box. I hope um, uh, I hope you guys like this video. If you have any queries related to this, just write your question. I'll try to solve it. Thank you very much and good luck. Thank you.